Hi students, today we'll solve a very interesting problem from thermodynamics. It's about cyclic process, and as you can see on the screen, the process involves first A to B, an isothermal expansion, B to C is an isochoric cooling because the volume remains constant, and from C to D is again an isothermal expansion. For the first isothermal process, the temperature is 2T naught, as you can see, and for the second isothermal process, the temperature is T naught. Now from D to A, the gas undergoes an adiabatic compression. It is given that the ratio of the volume at B and A and D and C, as you can see on the screen, is beta. Gas is helium and number of moles is 1. You can take any moles. I've just taken number of mole as 1. What we need to find out is the value of beta. So the question is asking you find beta. Now remember that by first law of thermodynamics, delta U or change in internal energy will be how much? 0, right? So delta Q is equal to delta W because delta U is 0 for any cyclic process. Now this is a very special cyclic process. See this, A to B, B to E and E to A. This is what kind of a cyclic? This is clockwise cyclic, right? And in clockwise cyclic process, the work done considered is what? Positive. And similarly see E, C, D, E. So the second cyclic process, as you can see here, this is an anti-clockwise cyclic process. And because E is the midpoint of B to C, which is given in the problem, so this means that the area, both the areas are equal and they will cancel out each other, right? Because one work is positive and the other work is negative. So A to B, B to E and E to A, this first work is positive and the second work is negative. This means delta W is 0. So this implies obviously delta Q equal to 0. So this is a very, very special case. Remember, like in any cyclic process, delta U is 0. Example of a cyclic process where work done as well as heat developed, these both are 0. Then this is the only process. You won't get this kind of a problem in books. We have to find out the value of beta. How to do that? To find beta, what I am going to do is that I will find out the work done of each process. So what is the work done in A to B? Because it's an isothermal process, so it's going to be NR, temperature of A to B is 2T naught, ln final volume by initial volume, which is VB by VA. Work done B to C. Now B to C is an isochoric cooling process. In isochoric cooling, the work done is 0. What is the work done in C to D? It's going to be NR, temperature is T naught, and now it's going to be ln final volume by initial volume, and the final volume is VD by VC. So ln VD by VC. Okay. Plus now the work done for the process D to A. D to A is an adiabatic compression. So for whether it is compression or expansion doesn't matter. The work done formula, remember, it is Pi Vi minus Pf Vf by gamma minus 1, or you can say in terms of temperature Nr Ti minus Tf by gamma minus 1. And gamma is equal to 1 plus 2 by F, where F is the degree of freedom. For monoatomic gas, the degree of freedom is 3. What is the work done in the process D to A? It's going to be Nr initial is Td, which is T naught minus 2T naught divided by gamma minus 1, and that is equal to 2 by 3 because of degree of freedom being 3, as the gas is monoatomic, and the total work done must be equal to what? 0. So what's the answer I'm getting? I'm getting the answer as 3 Nr T naught ln beta, because VB by VA and VD by VC both are beta, and here I'm getting minus 3 by 2 Nr T naught equal to 0. So I'll do the side change and I'm going to get 3 Nr T naught will cancel out. So I'll get ln beta is equal to half. So beta is equal to e to the power half or square root of e. So I hope you really liked this sweet, simple, short problem. Thank you for being there.